Hi, hello, and welcome to today's discussion on performance elevation using S3. So, why did we take S3 as the very first topic of our discussion? It has a variety of reasons, but our primary being out of the several architectural diagrams which you have seen, either in the projects in which I was engaged or even as references, yet to come across any architecture where S3 is not a component. The reason is, among all the storage solutions which are there in AWS, including EBS, your file system, then your Kinesis, your databases, S3 is the cheapest. There is no other solution which comes even closer to S3 when in terms of the cost. So any architect or designer, when they are putting together a new architecture, they are highly tempted not to leave alone S3. So that is one of the reasons why S3 is an integral part of most of the architecture, or in fact I will say all the architecture in AWS. Besides that, even people who are not from a technical background, and when they embrace cloud, especially AWS, I have seen them, they are very readily using S3 as their storage solutions. In fact, the cost works out to be much lesser than $1 for the entire year for more than 1 gigabyte of data. It depends upon whether you're putting it in the infrequently accessed or it is in the glacier or deep archive glacier. And if you are someone who hosts some of the events and you want to have a static website, needless to say, S3 is one of your go-to options, right? So given all these reasons, I have seen S3 as a common man's pen drive. So even in cases if you can't use your pen drive in some of the devices in the corporate network, most of the time accessing it S3 in a more secured way is allowed. Now with S3 being such a unavoidable component for these reasons which I just mentioned, we also need to know when more and more architecture are getting built leveraging S3, we need to ensure S3 is being utilized in the right way in order to give you the right performance impact. And in the next 15 to 20 minutes, we will discuss about 4 such principles. We will divide the whole session into 2 segments. In segment 1, we will discuss on the low-hanging fruits, the first 4 principles when it comes to performance and S3. The next session, we will deep dive a little bit more into the complex aspects of programming and S3, right? So let's take one at a time. The very first principle is, do not consider S3 as a single monolithic block of storage. What I mean by that is, in the traditional sense, when you have your on-prem server components, you will have a storage server. That is one big server. Maybe it has a huge capacity, depending on the network size and the number of users it is trying to serve. And it normally gets on to server harvesting, and you'll have more and more server connected together. But still, it is one block of server which is going to serve the entire network. But when it comes to S3, if you create a bucket, you need not equate it to something similar in your on-prem world. It is not one single server, but rather it is like a distributed network. So if I have to give you a very simple example so that you can understand this so-called complex terminologies, it's like this. In the mythical stories, especially if you are someone who is very interested in it, you would have seen there will be one monster who will suddenly replicate into 10 or 15 monsters magically, and the protagonist will be expected to attack and kill all of it. At any point in time, every monster, the replication will look identical in nature. We would have seen it or heard about it a number of times. If I have to draw a parallels, exactly that's what happens with S3. In S3, if you create folders, and AWS terms, it is called as prefixes. If you create prefix, each prefix will in turn act as if it is an independent S3 unit in terms of your concurrent users. So what I mean by that is, if you have a bucket, and today as we record this session, it has a capability to serve 3500 writes and 5500 reads at any given time in parallel. But if we create folders under the bucket, each folder itself will have the capacity to handle 3500 writes and 5500 reads independently. So storing data in folders not only gives you a sense of being organized and elegant, but also increases the performance. Now, because each of the folders can be accessed by more and more concurrent users rather than approaching that bucket at its root. So how does that help you? So assume that you are a machine learning programmer or you are an IoT programmer. A lot of data is getting into your system and you prefer to save that in S3 rather than dumping it at the root level. Organize it at a folder level, give any meaningful names to the folder. In fact, if 6 months before, if I have recorded this session, I would have suggested you to name your folder as the opposite or the reverse of the timestamp, because that was one of the performance technique. But AWS pace of innovation keeps increasing. Now no longer that technique is a recommended one. In the recent document they just said you need not take so much of effort in creating a random hash string to name your folder. So that is obsolete now. But coming back to the topic, if you create a folder and start putting in data and start accessing each of the folders, the degree of concurrency increases proportionately. That's a great thing about S3. And in a way, if I perceive S3, it is like a bottomless pit. You can store as much data as you need, and it doesn't enforce a particular format of data. That's the reason S3, in true technical sense, it's the data lake. And if you want to do some quick analysis on the data before even you put it to a proper data warehouse solution like Redshift, you have abilities like Athena and Glue, which will help you in writing some quick and dirty queries. The Glue will convert your S3 metadata into a schema, and then you can write queries, SQL queries, using the analytical engine called Athena. And all this on top of an S3, treating it similar to a database. So those are the additional powers which you get. But okay, not digressing too much, coming back to our point. So if you are using S3, remember this, creating prefixes or folder not only helps you in organizing your data, but also it helps you in increasing the parallel read and writes into your bucket, because each of the folder can accommodate as many read and write as that entire bucket itself. I will not recommend you to remember the number of reads and write because it's a fast moving innovation. So probably 1 year down the line, if I have to re-record the same session, maybe the numbers would have changed. But the concept remains the same. Each folder itself will support as many reads and writes as the whole bucket. That's point number one. Point number two, let's keep it simple. So if you are having an S3 and a server, or technically an EC2, keep them both in the same region. It will help you reduce the latency in the data transfer. Technically, nothing stops you from configuring your server, say in a North American region, and your bucket in a Asia Pacific region. It will work, but there will be some amount of latency in the data transfer, which will impact your performance. So if you bring it both together under the same region, that latency can be avoided. And the added benefit which you get is it will also save you cost, because there is no cost involved between the data transfer of a EC2 and a bucket S3, as long as both are in the same region. That was the easy one. The third one, if you have an architecture and you want to troubleshoot, saying that okay, there is some performance impact, how do you optimize it, and invariably it has an S3. What we have seen in our practical experiences, people often tend to lean towards S3, trying to increase its degree of parallelism and other things. A great thing, but the systematic way of doing it is initiate a transaction, allow the transaction to complete one full cycle, and identify the set of resources involved in the transaction and how much the resources are being consumed for the completion of one of the transaction. So let me simplify it. Assume that you have an EC2 server and an S3. Let's keep it simple. If an EC2 server is initiating a transaction which requires it to go ahead and load an object from S3 and then do some editing or manipulation of the object and put it back into S3. Now, how much CPU is being consumed to complete this transaction? Assume, I'm going to say 20%. That means theoretically that EC2 server at the max can handle 5 transactions. Practically it will be less than 5 because not your 100% of CPU is allocated for your workload alone. There will be some fragment which will be working for some of the overheads. But keeping it simple, if a CPU is getting utilized 20% to complete a transaction, then the maximum number of transactions this particular server can handle is 5. So even if you increase the degree of parallel processing from your S3 to 10, 100 or more than that, your bottleneck is on EC2. So in such case, it makes sense for us to look at other options. Either you might increase your capacity of EC2, may bring in EBS, optimized EC2 instances, which we'll deal in different section. But for your understanding, EBS optimized EC2 means it will have 2 channels. One channel to interact with your application and the other channel to interact with the network data. If it is not optimized, all this data has to go through the same channel, resulting in slowing down. So in this case, we considered a very simple example of EC2 and S3. But in an ideal scenario, you will have several components. You may have a database, you may have a cache. The cache may not be uh, having the right level of information always, so that the miss ratio will be high, or the time to live of the cache is very low, so volatility is high, or you might even have a database which is not performing well, so on and so forth. But the point which I'm trying to drive is, so if an architecture is not really performing well, uh, the systematic way of addressing it is going through each of the component and understanding how much of it is spent in completing a transaction, and then identifying the bottleneck, localize it, and then bring out methods in improving it. The reason why I'm driving this fact is it's not always S3. S3 plays an important role, but the tendency to believe that S3 is causing to slow down may not always be true. So that was your point number 3. Point number 4, easy one again. Use transfer acceleration to get highest performance. So transfer acceleration is, say, assume that you have a bucket and your architecture demands that the data to the bucket comes from different corners of the world or from different geographically distributed locations. It has to be uploaded. You can definitely make use of your normal internet, but the guaranteed way of bringing in performance is transfer acceleration. Transfer acceleration makes use of your edge location, wherein the data is cached, and not only cached, right, it is using the proprietary infrastructure of AWS, which increases the speed, because it's something like this. This is like a private expressway wherein not all the public transports are allowed. So in that case, the speed is guaranteed, whereas an internet is like a shared highway where you will have too many workloads depending upon the time of the day. So transfer acceleration is a way to improve your performance, and if you are someone who is skeptical about it, they have a tool to give you that confidence. So just go to Google, say transfer acceleration tool. The JavaScript based tool will pop up as your very first or second link. Most of the cases is the first link, and when you click on it, what really happens is AWS creates a dummy packet. It tries to propagate it to different regions through 2 channels, one using its own proprietary channel and the other one using your internet, and it gives you a comparative study saying that which one is faster by how much percentage. And this doesn't charge you, it's a free tool. It will help you to understand why transfer acceleration is a preferred way. So we have seen 4 techniques. Number 1, don't consider S3 as a single monolithic storage block, but rather get organized in terms of prefixes. Number 2, have your S3 and your server as much possible within the same region. It not only improves your performance but also decreases your cost, because there is some amount of billing which will incur if there is a data transfer between regions. Number 3, if there is a performance impact, study it holistically rather than trying to over-engineer S3. In the case which we just discussed, even if you increase the degree of parallelism in the S3, you wouldn't be getting your desired result in the architecture because the problem was somewhere else. The 4th point was use transfer acceleration to bring about a maximum performance if you want to upload large amount of data from geographically distributed location into one central bucket. These are the 4 low-hanging fruits which we just saw. There are 4 more concepts. I will not say it is complex, but I don't want to push everything in the same video. We will do a part 2 of this. And just to remind you again, we have a podcast on the same topic available in 7 different platforms, including Google Podcast, iTunes, and all the prominent platforms like Spotify. I will drop the link in the description section, but in any of the prominent platform, if you go ahead and search Tech Padasala, you will find our podcast there. Hope you enjoyed the session. If you have similar lessons or best practices or anything wherein you are struck with an architecture and you need some guidance, or you feel that we need to discuss or probably want to share some of your lessons learned, feel free to write to me at queryshami@gmail.com. You will find that in the description section of this video. Thank you. Meet you again.